Hello, everybody. My name is Aiden Ballack. I'm a senior at Texas State studying construction management. Today, my presentation will be covering rock blasting. So yeah, let's get started. This is my outline for my presentation. First, we'll be starting off with an introduction. Then we'll do the equipment related to rock blasting, the cost of rock blasting, safety concerns for rock blasting, uses in Texas for rock blasting, the summary and the conclusion, and then we'll follow up with a couple of questions. So this is a little introduction to rock blasting. Rock blasting is used in many ways. Some of the most common are mining, quarrying, and civil engineering. Civil engineering consists of making dams, tunnels, and roads. Mining and quarrying, they're used for aggregates to make stuff like cement, buildings. Quarrying, you could be using to get coal, steel, iron, stuff like that. Blasting is performed by drilling holes into the ground at the perfect distance and placing explosives in these holes. Once these holes are detonated with the explosive, it'll fracture the rocks to the desired size. Once we get to that, we'll use excavators and loaders and stuff like that to gather these aggregates and send them out where they need to go. So this is a little list of the equipment used. We'll start off with preparation. Laser rock profiling systems are used to determine the rock geometry to reduce incidents of fly rock. Fly rock occurs when they drill the hole and there'll be rock on top of the explosive that can be caused by, just like debris falling in after they drill, after they bore and put in the explosive. Air blast, it's basically the same thing as fly rock. It's the explosive coming out of the bore with basically projectiles coming out at very high speeds. You can think of it as a cannon. And then excessive vibration. So when you blast this, there's so much force used to blast and, break these rocks and fracture them that you are basically, you can make like a little earthquake doing that. So those are all things that these laser rock profiling systems do to make sure that these things don't happen. As far as drilling, this is how you make the bores to put in the explosives. So a couple things that you can use is a rotary percussive rock drill, a coal drill, an electric auger, and mobile electro hydraulic drills. Here in the illustration on the left, you can see they're boring holes. All these little flags are showing exactly where they need to bore. The holes have already been dug. And then last but not least is the blasting. So traditionally explosive with fuses were used. And then it was like in the movies where you see they push down the thing to detonate the explosives. We've come a long way from that. So now it's more of a remote controlled thing. But yeah, that's some of the equipment that's used. The cost varies. It depends on the area, the type of equipment being used. So if you're renting equipment, if it's not your land, of course it's going to cost more. But prices range between $5 to $45 per cubic meter. So yeah, it can be either really cheap or really expensive depending on if you have your own material or if you're using somebody else's stuff. So with blasting, obviously you're using explosives. There's rocks that you're trying to get, but these rocks can turn into projectiles. So there is a lot of safety concerns. Fly rock is one of the most dangerous aspects of rock blasting, and some precautions used in blasting are placing sandbags on top of the bores. Oh, excuse me, to prevent rock projectiles. So you can picture it as like a cannon and then them putting a choke inside of the cannon. So once it explodes, all that force is going to go up. It's going to hit the sandbag, which honestly will probably break, but it's going to cause it to not explode and send projectiles hundreds of yards and hundreds of meters away. Using correct sequencing, appropriate distance between blasts to prevent rock breaking and going to other holes. So this is kind of the same thing. You're trying to prevent the fly rock and the air blasts. So with sequencing an appropriate distance, you're making sure that once the sequencing of the explosions happen, that debris does not come in and fall into another hole and the explosion occurs and pushes all that debris out. Um, you could picture it as like, so there's a huge field, every, let's say 5 yards, there's a hole, going from left to right. They ensure that once one of the holes on the left side pops, that it's not creating debris to fall into these other ones. So it explodes, this one explodes, and if the rocks fall into that one, obviously they're going to come out and cause problems. Ensure appropriate drilling for boreholes. So the stratification of soils, obviously there's different layers of soils, and depending on what is getting blasted, maybe something will be at a different depth. They obviously calculate it with the lasers to ensure that they're drilling to the appropriate depth to put in this explosive and to make sure that air blast and fly rock doesn't occur. Using spotters to ensure that there is no vehicular activity around the blast site. This is also for pedestrians as well. A spotter is just going to make sure that nobody is in the blast radius or anywhere near any of these projectiles that could, which shouldn't, but could be coming out of these holes. So yeah, they play a pivotal part in ensuring the safety of pretty much everybody around. If there's, houses or anything, I mean, even within a mile, sometimes these rocks can come out. So there is a lot of things that go into ensuring that this is a safe thing. Correct compaction of the primer. So the primer basically is the thing that sits on top of the explosive. If the primer is loose, you can get misfires, and you could also get just basically blanks where they won't fire at all. So with the compaction of the primer, as long as you're ensuring that you did it right, it'll ensure that the sequencing and the sequencing will occur in which way they wanted it to occur. So with the primer being put in right, back to my analogy from the field with, every 3 to 5 yards, with the primer being incorrectly, it'll sequence perfectly and allow for a safe blast. Uses in Texas. So there is a lot of uses in Texas, actually. So Texas is actually the #1 producer of aggregates, and they use rock blasting as a means to harvest this and speed up the process. With Texas being one of the top 3 in building out infrastructure, that's including Florida and California. They need these supplies to maintain the demand of all these buildings being built. Like in Austin, you drive by and you see 20 skyscrapers being built at once. Every single one of these skyscrapers needs material, for the concrete pours and stuff like that. So there is a lot of use in Texas. I feel like a lot of the stuff that we do blast, we use on our own, but obviously we do export to states that don't blast as much. So, as a summary and conclusion, rock blasting is a high impact approach to collect aggregates and sediments for future building and mining. Blasting has been around since 1844 and is still being used now. So it's been around for a really long time. With the influx of new infrastructure, blasting and collecting has helped sustain the strain of all the infrastructure being built. Since its inception, blasting has become more scientific and safer. Precautions range from distance management to in-depth chemistry and physics. Rock blasting is continuing to innovate and adapt to new regulations and demand. Without blasting, the harvesting and collection of rock would take much longer than it does now. So the process of, rock blasting ensures that we can support all the building out of this stuff. It has been around since 1844. Constant advances in the construction field have been evident, and you can see in rock blasting it is as well. It's not just put an explosive in the ground and blow it up. They do break it down to a scientific level. Obviously, you have to control the blast. You can't put too much dynamite. And yeah, it can be simple, and it can be as in depth as chemistry and physics. So it's a little summary and conclusion. These are some references that I referred to for my presentation. I won't be going in depth. I covered most of the information that's on here. And then here's some questions to test your knowledge. Make sure you learn something from the presentation. So how does Texas rank in aggregate harvesting? Like we talked about before, Texas is one of the most built out and constantly being built on states in the whole US. So Texas does rank as the number one for aggregate harvesting. In what year was the first rock blast observed? Going back, 1844 was the first year that we observed a rock blast. Since then, there's been leaps and bounds in technology, specific ways that it has been done, ensuring safety and efficiency. What is the most dangerous aspect of rock blasting? So we talked about the the rock blast occurring, and then the air blast and the fly rock occurring after it blowing up. Obviously, with so much dynamite and explosive being put in the ground, it's very dangerous for these projectiles to come out at such a far distance and such a high speed. So yeah, I would say fly rock is the number one, I guess, most dangerous thing of rock blasting. So yeah, there are my answers for the questions that we just talked about. And that's it. I hope you guys learned something. Thank you.